Okay, hopefully that stays recording this time. Last time it shut off on me. Okay, so we're looking at lecture 26, inverse trig functions. Fact number one, we know from functions that to have an inverse, a function must be one-to-one. Now I'm going to jump here real quick. What does an inverse do? Because we're talking about inverse functions. What exactly does an inverse do?
Finds like the opposite.
Say that again?
It finds the opposite.
It finds the opposite. Yeah. Okay, yeah. So it maps. So let's say we have our mapping. We use that symbolism. And I have my domain and I have my range. And I have whatever function I have in here. And it takes 2 and it maps it to 5. It'll take 3 and it maps it to 6. It has 4 and it maps it to 7. Yes, I did 6 and 7 on purpose. All right. So we have our function, and that's the mapping of it, right? So an inverse does what? Well, exactly what Omar just said. It says, here's the 5, it maps it back to 2. It takes the 6 and maps it back to 3. It takes 7 and maps it back to 4. Okay. So what does a one-to-one function look like then? Well, there's a one-to-one function. 2 only goes to 5. 5 only comes back to 2. Okay, so let's look at one that's not going to be one-to-one. Let's take a function and let's say 2 maps to 4. And then let's say negative 2 also maps to 4. What's my function there?
What's your negative 2? Your function.
How do I get from 2 to 4 as well as negative 2 to 4?
Because you multiply negative 2.
No.
Because you squared it.
Squared. This is my squared function. This is f of x equals x squared. Okay, that's my function. Now, that is a function. But it's not one-to-one. Because as Omar said, if I give you the 4, what's it map back to? 2 different possibilities. Okay, it can be the 2 or it can be negative 2. Okay, so it's not a function. It's a function, but it's not a one-to-one function. Okay, so a one-to-one function maps you from the x to the y, goes back from the y to the x. So there has to be only one x for every one y. It's one-to-one. Like in basketball, you're playing man-to-man. It has to be one-to-one. Okay, so to have an inverse, a function must be one-to-one. Now, sine and cosine are clearly not one-to-one. How do we know that? How do we know that sine and cosine are not one-to-one? Say it again.
Y value.
Say it one more time.
They go over the same y value.
Absolutely. Look at you in a circle. What's the sine of pi over 6?
30
Say it again.
30
30 degrees. What's the sine?
Sorry.
Pi over 1/2. What's the sine of 5 pi over 6? It's also 1/2. So if I give you 1/2, what do I map back to? Do I go back to pi over 6 or do I go back to 5 pi over 6? Or do I go back to 13 pi? Let's go to degree. So you're looking at kind of sharp. Let's go back to degree. If I give you 1/2, what's the angle measure? Is it 30? Is it 150? Is it 390? Because we go 360 plus 30. Do I do a full revolution? Do I go backwards to negative 330? These are all give me a sign of have a sign of 1/2. So I don't know which one to go back to. There's an infinite number of possibilities. In fact, we call that. Do you remember how we test it? A horizontal line test. 1/2 goes back to an infinite number of possibilities. So to have an inverse, a function must be one-to-one. Sine and cosine are clearly not one-to-one. Okay, they're clearly not that. So how then can I have an inverse trig function? I asked you this question, maybe a week and a half, 2 weeks ago. Has anyone figured it out? How can I have an inverse trig function? I mean, we obviously do, because that's the name of the lecture. Any ideas? Yeah.
Okay, this is not a good idea, but it was like, the way it works is that you reverse it and you just use the y value multiple times. So like, where you say where you don't know where it maps back to, it maps back to both. So like, one of it, like let's say 2 and -2 both go to 1, then when you draw it, it will be 1 and 1 both go to 2 and -2.
Okay, but by definition, by going back to two values, it's not an inverse. I can only go
That's
back to one value. I can only go back to one. You see the problem?
Yeah.
Okay, you see the problem with that thinking though? Going if -2 and 2 both go to 4, 4 can't go back to 2, it can only go to 1 of them. Okay, and it's because it goes back to 2, it's not a 1-to-1 function. Okay, so how do we do it? How do we get by that? Let me ask you this question. Jasper, think about this one. Now, in respect to trig functions, what would an inverse do? It would be finding the what? If I did inverse sine, so I take the sine of an angle, and it gives me a value, right?
Mm-hmm.
So let's write this out.
Wait, would the function be, if it's sine, would it be cosecant or would it be inverse?
Hang on to that, because that's an ambiguous situation we're talking about. Okay, that's a very good point. So let's look at this though. If I have the sine of, do you guys want to do degrees or let's just do degrees? Sine of 30 degrees, we know is 1/2, correct? Okay, so I have the angle, I can find its sine. Inverse does the opposite. Inverse says, okay, if I have the sine inverse of 1/2, the inverse sine of 1/2, it's going to give me what is my answer? It's going to give me the angle measure. It's going to give me 30 degrees. But the problem is, it could also give me 150. It could also give me 390. It could also give me 510. All of those angles have a sine of 1/2. Okay, we have an infinite number of possibilities. So how do I then say, I'm only going to go back to one of them? Okay. So in respect to trig functions, what would inverse do? It's going to give you the angle. So when we're looking for an angle, we're going to be using inverse trig. Okay, what would it give you as the answer? It's going to give you the angle. So solution to this contradiction, here's the answers. Okay, we have to start by, and I apologize, I should have this done already. Let's go put the grid lines on. And we're going to go back and do our little diagram again. We're going to sketch out our, I'm going to make it a little bit bigger than I have in the past. Pi over 2, pi, 3 pi over 2, and 2 pi. We're going to make one period. And then I'm going to go up here to 1 and down here. That way it's just a little bit bigger, easier to see. Okay? So let's use the sine first, the sine of x. So we're going to go 0 to the 1 to the 0 to the -1 back to the 0. Here's my function. Now, in this one, I'm going to go ahead and take it back as well. I'm going to go back here to negative pi over 2. And negative pi over 2 would give me down to -1. Because we know it continues forever, right? And we continue forever. Okay. So I have the sine function. Now, what is the range? Yes.
Does it go upward? Like, is it a vertical squiggly line? Because you would flip what values, it would go by radians on the vertical axis.
Are you talking about its inverse? The graph
Yeah.
of its inverse? Hold that thought.
Okay.
You're really thinking well, and I appreciate that. But no.
Okay.
And here's why. The problem is, I can't go back to two values, and I know right here, if I give you y equals 1/2, it gives me two different values. Okay, even just in the first two quadrants, it gives me two different values. So here's what we're going to do. What is the range? Someone tell me, what is the range of sine? What is the range of sine? Say it again. Domain is all real. What's the range? -1 to 1. So what that tells me then is, if I give you something like, in fact, you can check me on this with your calculators right now. If I do inverse sine of 3, what's inverse sine of 3?